Hey everyone, I'm Jeff Dickey from Redapt.
I'm Nikki Acosta from Cisco, and we're back, we're back, we're back, we're back, we're back, we're back. We are back from a hiatus, and I am super, super happy about our guest today. Mark McClain, introduce yourself.
Hey, so my name is Mark McClain. I am the CTO of Akanda, Inc. I've also been in the OpenStack community for a good while and been serving on the technical committee. This is what I'm finishing up my third year on it. So.
Woohoo! And we typically like to start these things out by learning more about you. I just learned that you are in the awesome city of Hotlanta, but tell us about your journey into tech, into OpenStack, and then into Akanda. What has that been like?
So my journey in tech was kind of easy. I don't know. I always grew up just playing around with computers. Love programming computers, doing that since the time I can remember. So naturally, when I went to school, that was like an easy choice. And so went to Georgia Tech, got out, worked for a couple companies here locally, and then started working more with a couple of California-based companies. And so transitioned from one to another where a couple of people had moved, and so I ended up working and going to work at DreamHost, who's deploys their Dream Compute and OpenStack product, which is how I originally got started into OpenStack. They were recruiting to fill out the team. They're like, hey, we need some folks to come work on OpenStack. We also specifically need some folks to come work on networking in OpenStack. And so I was like, with OpenStack being Python based, and I've been working in Python now for 15 years, it was easy. It was an easy no-brainer, and it's been an exciting ride to say the least.
So now you're at Akanda, and for folks that don't know what Akanda is or does, give us the pitch.
So Akanda is network service orchestration for OpenStack, and it originally came out of a project that we started back in 2012 at DreamHost that was spun out into a separate company. And realistically, what we want to do is, being operators and deployers, we knew that we were going to deploy a number of different network services and functions over the years, and we wanted an easy way to manage them. Taking a look at, because there's a number of good off-the-shelf solutions available from a lot of different vendors, but they a lot of times don't play well with each other or are very hard to combine and easy and difficult to operate. So we wanted to make it easy to operate them, make it easy to manage them in a virtualized environment. And so that's kind of how the Astara project was born.
And so for folks who aren't aware of what Astara is, what is the relationship of Astara to Akanda?
So Astara, so Akanda, the company, was what we formed, and so when we started having discussions from day one, our DNA has always been let's upstream, let's open source the software, and so that was always one of our long-term goals. And so when we started talking with other members of the technical committee and foundation staff about how we can have the project join the OpenStack Big Tent, one of the things that kind of came up is we wanted to make sure that the Akanda name, with us being a company, for some felt like it wasn't going to be a very open environment, and so we're like, okay, that's fine. We care more about the community and growing it than our brand. And so what we decided to do is, by renaming it, saying this is a star, this is a community thing, and that Akanda itself provides professional services around operating a star. And so that's kind of how it was born. And the name itself is kind of interesting. Akanda is Sanskrit, Astara is Sanskrit, but the running joke with the project is, central to it when we started, the original name for the project was called The Rug, after a reference in The Big Lebowski. There's a line in the movie that says the rug really tied the room together. We always looked at networking as tying the room together, and so Astara is actually loosely translates into rug. So from time to time, if I ever talk about Astara, I may mention the rug, but it's the same thing. And so, yeah, it's just kind of a Big Lebowski reference, complete, with bathrobes, white Russians, and, slippers and all the stuff that goes along with the movie.
Yes, I bet your holiday parties are fun over there. So, Edgar Magano, who we've had on the podcast before, formerly at Cisco, now at Workday, great guy. He had some questions for you when we posted today that we were going to be meeting with you. And while I think you've sort of addressed parts of those, he wanted to know why you're doing all these good network improvements as an open source project instead of just pushing all that into Neutron when you have the PTL on your team.
Yeah, so I mean that's a very good question, and so it's kind of interesting because having been PTL, it's like I have the experience. I know what both Kyle and Armando, and Dan, who was the original PTL. It's like we've all kind of walked in the different shoes, and managing the project. Networking is a really really big field, and one of the things is that we always kind of ran into this tension between either having like, do we implement a networking solution that integrates well with hardware, or is it virtualized running in, say, a container, or is it running in service VMs? And so you typically had, or is it open flow where you're doing all the networking, basically managing a virtual switch? And so we'd end up working through that, in those different camps, and they all kind of had different opinions on it. And so rather than kind of fight that battle, because if you look at what the reference implementations are inside of OpenStack, they're all basically network namespace implementations. Oddly enough, were never really designed for production usage. Instead, over time, they've morphed into being production ready, because realistically, everybody thought that Neutron was going to be an API, similar to how Nova is an API, which abstracts out KVM and Zen and Hyper-V and the different hypervisors. That Neutron would be that same way. And so when we started taking a look at where's the proper home for Astara, so we have pushed some fixes upstream in the Neutron, and we fixed some bugs into the common areas. But as far as an actual implementation, I always thought, just from my experience at PTL, I thought it was better that if we had the implementation was a standalone project, because different implementations, if we were just to declare one winner, I think we'd do a disservice to some of the deployers who are, in deploying OpenStack, because the operators have different choices, different requirements, whether they're running, a public cloud or they're running a private cloud, and so, trying to force one down, realistically, from an open source perspective, didn't kind of feel right for us, because there's some good open source solutions out there that are doing networking a slightly different way, but are solving a different set of problems than we're setting out to. So we'd rather just be an open source project and say, hey, this is what we're doing, and borrow and share ideas from everybody.
So what is the relationship now between Astara and Neutron? Like, where are there parallels, and how are they different?
So the biggest thing is that we still support the Neutron API. As a matter of fact, Neutron is a service you run. It's the API that we support. Astara itself is an implementation for network services managed by Neutron. So from the tenant perspective, they're always seeing the standard Neutron API managed by standard tooling, nothing special required to run. But from an operational standpoint, Astara is in the background actually taking the logical routers, taking logical load balancers, and creating those services and provisioning on behalf of the tenant. So the operator is the one that sees Astara more than the tenant side. So it's mostly a plugin that's kind of selectable depending on which services the operator wants to deploy. And then we also integrate well with a number of different services, because we took a look and said we really didn't want to go build a layer 2 networking solution so that we could work seamlessly with, say, Open vSwitch or Linux Bridge or commodity switching or even some of the proprietary solutions.
But now, are you dependent on Neutron?
Yeah, we are dependent on Neutron, and we've said from day one that we don't want to replace Neutron. We think that having a common API that supports common tooling is really what's successful for everyone. It's easier for operators, it's easier for developers who are building solutions on top of the infrastructure, and so we've never really we're not seeking to replace it. Instead, we want to provide a implementation that's open. Also, when we have new ideas, we've been working with others upstream in terms of how we integrate well with some of the other projects, or proposing new extensions to Neutron that says, hey, this is a need. We want this API to be shared by multiple providers, because one of the things I think that from the deployer side, I think we've all kind of been burned over the years if you work with deployers, where you have like this proprietary API and then you get like this sticky point that you can't move, you can't change, because you've written a lot of tooling around a specific solution. And so we would really believe that being open is the way to go, and that it's the solution that people care about more than the interface to it.
So in terms of just Neutron in general, I've been racking my brain because, as of the last summit, of course in the keynote they talked about how it is now, the #1 product or project in terms of contribution. But it just seems like, because there's not sort of one clean way to do it, I think we're almost in a state where at least the folks that I talk to that are interested in deploying OpenStack kind of have analysis paralysis. There's the hardware gateway models, there's overlay models, there's software virtualization-based models. Like, how do you make sense of everything that's going on in Neutron?
I mean, I think that's a difficult challenge. It's what's propelled the growth of Neutron. It's also what's made, as far as community, it makes Neutron very interesting and dynamic because you can talk with a number of different people who have different problems, all surrounding either preferred technologies or solutions they want to seek. And it's kind of, on one hand, I think, and talking with some people, and some of the docs team's been slowly, not really slowly, but has been steadily working towards improving the documentation around it, because I think what I run into frequently is there's like this mystique around Neutron that you have to be some crazy guru of networking, and in fact the very basic components of Neutron can get you a very functional network pretty quickly that doesn't have overlays, doesn't have a lot of different bells and whistles, but for some deployments will get you out of the gate and running them very rapidly. And then I think really kind of messaging Neutron is like, hey, the complexity scales with you. You can have a very simple deployment and do lots of really cool things with it, or if you need more special features, you can go slowly roll those out without having to like boil the ocean and decide that we have to have a bake-off of like 10 different solutions, all ready for massive scaling. And it's also kind of challenging because if you compare it to, say, with storage and sender, the footprint's very kind of set up. It's like, I've got my block storage, I've got a very well-defined API, but for the most part, those are kind of black boxes that hide behind the API, and you can kind of hide some of the details. But with with networking, it's a little bit more interesting because you have so many components. You have interoperability challenges that if you select, say vendor A, you may not be able to run stuff from vendor B because maybe the MLAG may not be compatible between the two if you want to say do some of that, or if you want to run some of the systems that have either orchestration or policy sharing, or some people really love OpenFlow, some people don't, and so it's the choice is kind of good. Also, the space itself is still growing. I mean, if you think about in terms of like the rapid rise in terms of like people understood what the term microsegmentation meant and means, say in 2013 to now, I mean, that's been a huge change as well. And so I think there's still a lot of things that have to shake out. But underneath the hood, the traditional networking components that we've all used still work and work very well. And so you can kind of pick some of the basics and start with that to kind of really gain understanding with OpenStack versus saying I have to pick my end solution now.
So are you of the belief that, a large-scale sort of OpenStack implementation necessitates a classically trained network administrator? Because it seems like, with a lot of these solutions, you've almost kind of made his compute and storage as an example. You simplified that to the point where a developer writing an application can leverage the services without any knowledge or expertise of what's really happening behind the scenes. But it seems like with networking, it's almost like you still need a network administrator in the background, and then at that point, how much complexity are you introducing into writing applications when you may need like that manual assistance from a network administrator instead of just leveraging an API.
Right. Yeah, it's interesting. The other kind of interesting thing is that in a lot of companies, you have a separate networking team and a separate compute team, and so you get some of the it's a lot of times it's how communication flows between some of the teams. Some of them are very integrated very well and work pretty rapidly, and but other times you have where it's there's a formal process in which you get provisioned network resources. And then I think one of the other interesting challenges is that if you take a look at some of the other cloud models, is that OpenStack's model, the networking model in the current API, is very layer 2 centric. if you take a look at the applications that run on it, most of them don't need a lot of layer 2 support. I was talking with some folks in Tokyo. It's real interesting when you start taking a look at, say, applications deployed on Amazon. A lot of them, unless they're using VPC, don't really care about being layer 2. And so you can kind of get some freedom. It's like, just give me connectivity between all my servers. Tell me the IP address. I don't really care about how, in some cases, people don't care about how the addressing is laid out. And that's kind of, and there's some work going on in that area in terms of Neutron, trying to basically, the Neutron give me a network model, Brian Haley's been working that direction the last couple of months on just, let's make networking simple for the simple cases, and when you need advanced features, you can go find them. If you care about how your instances are addressed, you can set that up. If you care about how the routing works between them, and start kind of making a little bit easier curated set of just kind of same defaults, so that people don't have to understand every little bit of networking. I think, it's always kind of interesting in hindsight. It's like, if we could have kind of flipped that script and started that direction a little bit earlier. Nova Network did that. Nova Network does that quite well. But the motivating factor for starting NetStack, Quantum, now Neutron is like, people wanted advanced networking features, and so we jumped straight to that without handling the easy case.
So is any of that part of what the Astara project aims to solve for people?
So Astara is trying to make the operations of say the network services. So if you want a load balancer, you can click go and you can get a load balancer. But from the operations side, that load balancer could be backed by a number of different vendors, some who have OpenStack support and some who don't currently. Kind of the nice thing about the service orchestration is that it's very easy to write a driver, drop it in, and then that service is now managed. The load balancer is available to the tenant. All they've asked for is just like a simple load balancer. They haven't really given a thought to, is this load balancer provided by vendor A or vendor B? But from the operations side, a lot of times you care because maybe there's a cost basis or maybe contractual basis. Also, some people have different workloads based on, and this is like with the newer flavor framework coming in, is that now you can actually you can differentiate your service based on cost to provide it. So that if you have a production workload, maybe it's behind the scenes run on bare metal hardware, but if you have a dev test workload, maybe it's run on in software. And
so I want to get back to kind of the product, and where do people kind of, what are the use cases that they're kind of coming in to kind of kick the tires of what you guys are doing, and how does it differentiate from some of the other folks like PlumGrid and Metacura, and how's your approach a little bit different?
So I think our biggest approach is we've tend to, a lot of folks who really love what's going on in the commodity switching space with the white box switching. Typically, if they're really interested in that, and then on top of that, they're interested in our product because we're layer 2 agnostic. We like to keep things simple. In terms of if you're really with commodity switching, I mean, it's they all look like servers. In terms of maintenance and operation, you have automation there, and so that's kind of where that use case where we're coming into it. We're also seeing a lot of people who need microsegmentation, but also don't necessarily want one of the challenges with some of the solutions, both open and proprietary, is just that they're these big monoliths that you drop in your data center, and that magic in, magic out. Troubleshooting for some of the solutions is some of them have very good troubleshooting tools. Some of them don't have the troubleshooting tools, are kind of a challenge. And so our approach is a little bit different, which is the networkings and the fundamentals of networking have existed for quite some time. They're well understood by lots of people, so let's embrace them where we can. You can get some efficiencies by converging some of the layers in the stack together. But with that efficiency, you also make it harder to troubleshoot, harder to operate, and harder to manage. And so, we're trading off a little bit in terms of ease of operability for a little bit of efficiency loss, and kind of tilting that coin of which costs more, operations, or having the operational man hours to run something, or just the capital cost of installing it.
I'd like to get your thoughts too. Versus Cisco's approach. Cisco has ACI, Cisco has a tremendous amount of networking expertise and obviously an opinion, but I'd like to get your thoughts on that overall.
Yeah, it's kind of cool when you think about it, that you have one of the dominant vendors in networking is participating in OpenStack who has solutions they're trying to integrate well with OpenStack. And when you start taking a look at Cisco's product line, they have a wide range of solutions across the spectrum, and oftentimes we'll have products in-house that actively could compete with one of their other products in-house. So I've always found that interesting in terms of ACI. What we run into in the field is that there are operators who love it, and it's great. We can embrace it, and then there's others who look at it and say, I get what it's trying to do, but for what I need in my particular use case, it doesn't really fit well. And so, that's kind of, it's the cool thing about networking is we have a wide variety of solutions, and getting back to the original kind of fundamental of Neutron, which is we have this technology agnostic API, which can then drive a number of different solutions. So that's interesting from that side. And so, I think there's still going to be some shakeout. There's lots of confusion in terms of, what's going to win over time. Because mainly I think people are still trying to figure out, how the different solutions are driven. It's very disruptive with all the different open switching platforms that have been released over the last couple of years. That's obviously driving costs down. It's also, making some traditional vendors do some things we thought we'd never see. I mean, you start seeing open switch, you see a box capable of, the open network infrastructure, and who would have thought that you would have seen that from a traditional network vendor 2 years ago? So it's, I like the disruption, but I also like the fact that the traditional players are trying and have different, it's just kind of interesting to me, the different solutions. And it's the same with kind of hypervisors too. It's like no one size fits all because everybody kind of has their thing they like. They also, in-house talent also kind of a lot of times dictates which solutions you can choose as well. And so some people are very well versed on, on the Cisco ecosystem, understand ACI, and so from a deployment standpoint, it's a natural fit.
And that was Edgar's other question. Specifically, he said, when is this SDN madness going to be over, and what technology will be the leading one, and why? Who's the winner?
So when is the madness going to be over? I don't think the interesting thing. I don't think it's going to stop. I think we're always going to see people pushing the envelope. The winner is going to be ultimately. I hope it's the operators. Because I hope that we end up with a rock solid tool set that's easy in solutions that are easy to deploy, easy to manage. In the interim, there is a little bit of shakeout in terms of if you talked 3 years ago, some people loved, thought that OpenFlow was going to be everywhere, central controller, control all your switches, and now what you're seeing kind of the other side of that where you get like, the OVN project, which is here, we're going to have little microcontrollers managing that OpenFlow switch. And so it's been interesting as you take a look at where people have determined, hey, this is a tool, this is the job this tool is very well specific, very well specified for. I think that's what we're kind of seeing shake out. And just the other thing is that some of the solutions at the time were very good, but over time I think we're seeing you get some of the disruptive where people say, oh, hey, we could do this, but we could also make this easier to operate. Or if we distributed this better, we could have higher availability, higher reliability. And so I think those are some of the things also shaking out as well. You're kind of seeing kind of that next generation of companies. You had like that first round of SDN companies, and then that kind of shook out, and now you're kind of seeing like another kind of round of networking companies providing solutions. And I think that's going to kind of distill down a little bit more, and we'll kind of keep progressing that way. Ultimately, I do think there's going to be a world where you'll kind of have some kind of combination of those, the ecosystems where you have something that's based, along the virtual switching side, and then, but at the same time, there's folks who are improving the networking stack within the Linux kernel itself, so that you could run traditional Linux bridging with the same kind of efficiency. And different operators have different opinions about which one they like. And so I think over time, I think we'll probably see kind of like those two kind of basic camps for virtualization, and then the ecosystems that support it around it.
How are containers impacting Neutron, if at all, in terms of either running components for Neutron in a container or managing containers using Neutron?
Yeah, containers are interesting. The Courier project I think is really cool, where they basically take in and bridge Neutron back into containers. The one other thing about containers is that you end up with an explosion of endpoints, and so when you have either bare metal or you have VMs, the number of IPs you'd be consuming and the amount of computation required to do some of the flow calculations is pretty well known, pretty easy. But when you have containers, you're now running high density per box in terms of endpoints, and so now that changes a lot. It also changes in terms of how bandwidth is allocated, what's the appropriate way to route. But that's kind of the interesting. That's one of the space where you're getting a lot of innovation. But at the same time, the container. The container discussions are somewhat interesting in terms of how networking was structured, because if you were to take those discussions and how libnetwork was formed, it essentially was almost parallel to some of the discussions we had in the early days of Neutron. There was one particular thread with some container networking one time. I sent somebody an email. I was like, haven't we read this email before? And said, substitute these names, and just got. And so it was kind of like we're all sharing a laugh, because it's like we've seen this email like a billion times. But it's interesting. I think running the services and containers, Neutron network namespaces are one of the key components for running some things in containers. Network namespaces, once you combine that with some of the other services, that's basically what forms a container on the host. So, we've been doing containerized networking almost since we introduced the DHCP agent.
It's been a minute.
Yes.
So, in terms of it's so funny. I remember being at Rackspace. It was probably, I don't know, at this point maybe 5 years ago, and there was some internal memos written about IPv6 and the impending doom that was coming. Yet I still see that there tends to be a lack of support for IPv6 in OpenStack. What do you think about that?
Yeah, IPv6 is it's interesting because it's like we're technically out of addresses, but yet the secondary market for v4 addresses is healthy, and you can still obtain blocks of v4 addresses pretty reasonably in price. But I've always wanted to see a better adoption of IPv6. Even back in Tail and Folsom and Grizzly, we started working on that. Astara, when we founded the project, was designed to be IPv6 from the ground up, and support it from the ground up. And v6 is challenging enough in terms of there's lots of support out there, but a lot of times the tooling for supporting v6 and v4 is a little awkward in some places, and so having to go through and kind of smooth out those warts, which is kind of odd to say. V6 as a standard was ratified 20 years ago. Basically started 95 and 96 was when they were. 95 was like when one of the drafts came out, and it's like, hey, shouldn't we be doing this by now? But it does require some changes under the hood. It does require a few adjustments. Getting the from the Neutron side, we were able to start supporting IPv6 for tenant traffic in some networks pretty quickly, but then you have to go through a whole kind of other issues like how are routers configured? Does DHCP? How do we assign addresses? Because there's different, and again, there's the different policies. Some people love doing DHCP. Some people, when it comes to v6, love Slack, which is just auto configuration. And so having to deal with both of those, having to deal with v6 addressing. Kind of the cooler thing with the cloud is that it gets rid of NAT. So a lot of the clouds that were based on NAT, with v6, you no longer have to do NAT. It's a lot cleaner. It's a lot more efficient because you don't have to go through and mess with the packets as much. So I think we're getting there. Even in the Liberty release, we now have prefix delegation, we have Slack, we have full routing support. Kind of the next big thing is you take a look in terms of the Mitaka roadmap and even into N is dynamic routing. V6 really excels when you can do some BGP and you can announce reachability. I think once we're able to do that, that's gonna really change a lot. Because right now in the existing Neutron, you have to do static routing, and so v6 with static routing can kind of be a little bit it requires a lot of manual configuration. For us and Astara, that was one of those things where we wanted to run ahead of the community and kind of try it out a little bit and see what things look like. So Astara's been doing dynamic routing now for 3 years, and what does that look like in OpenStack? How does that function? And that's kind of the nice thing about being a separate open source project, is that we're not necessarily tied to the stability cadence of Neutron. I mean, Neutron's got to provide backwards compatibility, and the challenges with APIs is that once you make an API, you really can't abandon it because people are going to write tooling around it, and so you got to make sure you get it right. And so going through and understanding that, I think, has really been a good exercise, and I think now you're starting to see a lot more support for V6. I think you're also starting to see a lot more V6 in terms of residential networks. So like a lot of people's home routers are now doing V6. But then on the flip side, you're also starting to run into some of the weird random problems that just kind of take time to resolve in terms of, making sure, load balancers and whatnot are configured properly, and kind of shaking out some of the weird random bugs.
So there's a light at the end of the tunnel. That's what I'm hearing you say.
There's definitely a light at the end of the tunnel. I think long term, I think V6 is it's definitely going to win out. The V4 secondary market will dry up. You can only apply so many Band-Aids. Sure. I think, it's interesting, though, a lot of people are really afraid of, say, like NAT, they think NAT provides security, which is kind of, we always talk to people about V6, and they're like, well, I'm losing NAT, and, now everybody can know my endpoint address of the host. It's like, you could always figure that out before anyway, for the most point. So it's going through and taking a look at, I think that's going to be one of the wins, is kind of defeating some of that mythology around network security that people mistakenly thought they were getting, and really having that hard, because security is hard. That's probably, I think, one of the next kind of big wave is, how do we get better at securing these? How do we get better at detecting? Now we have basic networking. You can really do some cool applications in terms of, making sure that there's, no lateral movement in the data center, or making sure that, particular data, that sensitive data is not being exfiltrated, because you're able to do that packet processing that you necessarily couldn't do before because it was computationally too hard in a central location.
And what about upgrades? How are people who are, you seem to be pretty in tune with the operators of these implementations, like how are people responding to the complexities involved in upgrading between releases?
It's been interesting. Some people are deathly afraid of upgrading because they've heard the horror stories, or they've been scarred, and I think we've, as a community, have done a tremendous amount of work to improve our upgrade story. I don't think, we still got more to go. If you take a look at, Neutron this cycle has some people in the community working on how we make upgrades easier. It's kind of challenging because you're basically replacing the engine while trying to keep the car going down the road. And so how do you do that in a sane way? How do you do that? That's also, uptime is kind of in the SLAs that different clouds have, make it kind of a challenge, because some folks are fine saying, hey, Saturday, your workload's going to stay in place, but you can't manipulate it, you can't run the API. Other people are like, I can't have more than a 5-minute outage ever. And so, how do you balance those two different things in terms of upgrades? So we're getting better. We have rolling upgrades are getting closer. I think we can kind of smooth out some of the warts. It's definitely a lot better than it was in the early days. I think, though, with Mitaka and doing the community work there is going to really assist it. And kind of the other challenge with upgrades is, that's upgrading OpenStack. We've also run into not necessarily upgrades, but if you just talk in terms of migrations from one provider to another, how do you do that in a running cloud? Right now, that's almost a cottage industry, and most people would rather stand up a parallel cloud than, say, transition the networking in their cloud. They would just, it's far. Everybody looks at it and goes, nah, I'll just move all the workloads that I can and make, versus try to seamlessly migrate it. And so that's one of the things that, in terms of how Astara's doing network service orchestration, is trying to kind of ease that burden a little bit, because we actually have run clouds running a star and actually help them like replace their layer 2 provider, for instance, so that if you do start small, you can switch to another provider over time.
Kind of a last question, because I battle with this mentally from time to time, but of course the word hybrid cloud means different things to different people, but it seems like as people start to get a little bit further down the path in terms of maturity around cloud native applications, they're also needing to be able to connect their cloud native applications to legacy data storage systems, all kinds of other things that might serve a different purpose, or might be the source of database data, for example. There are some people that think that this is actually a network problem, and there's other people that say this should be handled at the application layer. If I want to take my private cloud and I want to connect it to AWS so I can take advantage of Glacier or whatever, some people think that's a network problem. Other people are like, well, wait a minute, I don't need the network to do that. I can just do that at the app layer. What are your opinions on that? What is the right way to be able to achieve hybrid? And is it an application layer problem, or is it a network problem?
A little bit of both. So because there's a couple different things you really have to think about. So when you're kind of stretching, in some cases you have legacy systems which need to, the systems were designed to assume that they were located on the same network segment, and so then when you start stretching that between two different locations, that's a networking problem, because you can do encapsulation, you can tie together two layer 2 segments, make them appear adjacent to each other, and then, but on the same time, you also run some issues where the application has assumed that, hey, everything I'm talking to is in the same building, and so you run into network timeouts, and latency kind of creeps up, because anytime you start stretching networking, latency becomes kind of an enemy. And so that's one side where the application has to be a little bit more resilient towards it. I think, though, ultimately it is a little bit of an application design where you start getting applications that were designed to run, say, in layer 3, and just, you can plug in addresses. You have service discovery or other broker services that allow you to discover the location of the endpoints versus having them configured. But networking still provides a vital role for that, because networking can give you that secure channel, that can give you that VPN that's connecting the different endpoints together. It can also allow you to run, say, non-traditional, or not really non-traditional, but other protocols that aren't widely supported over the open internet. So, like often you can find UDP, TCP, and some of the control protocols, but if you want to run, say, a different IP protocol because you have a particular application that needs to take advantage of it, some service providers will just drop it because of how they've configured the network. And so, networking allows you to do and run some other, run some of the other protocols over the network transparently and as securely. And also, firewalling, it's like, how do you manage it if it's everywhere? So, if you take a look at having a holistic network management, you can have a consistent distributed firewall policy, for instance.
That's a big deal, definitely in the enterprise space, for sure. I mean, we're seeing a lot of demand for solutions that address data sovereignty. Like, I got to make sure that my data never leaves my country, no matter what, under any circumstance.
Right.
Which is a lot harder than you think. You start talking to one service and realize that that service might exist somewhere else. It's the cloud. It's just someone else's computer. No one knows where that stuff lives. And
especially like when you start seeing the rise of, say, some of the global load balancing projects, which you don't actually know where that endpoint is. It's going to pick one that's closest, but it may not actually be one that you can legally talk to. The other interesting thing when you talk about hybrid cloud, but on the networking side, is the reverse, where you're starting to see kind of a rise of some customer premise devices that can actually push the cloud into offices and into homes, where you can provision and virtualize network applications on the end user's device, so that you can actually push virtual machine images or containers down to the host, and so you can provide certain network services local with the same cloud management that we've been using to manage virtualized devices. If you take a look at some of the NFV space, they're centralizing some things, but you can take a look at some of the other folks where they're running virtual switching to, say, provide transparent provider selection of network transit. Basically by giving everybody the same little device in their house, and then you can go in and select, say, today I want my bandwidth provided by, vendor A, and tomorrow I can get one from vendor B with different SLAs. And so it's kind of cool to see the different virtualization applications also in terms of virtualizing on-site customer services as well.
Who's doing that? That sounds super interesting.
So there's a couple of people in NFV space. Juniper released their CPE device that integrates well with Contrail. I expect to see some more. Obviously, the rise of white box switching. I mean, you can install almost anything on the end of this on the end of the switch, and so when you start to, as the processing capabilities get better there, pair that with some of the ASICs, you can really do some interesting things. Also, I know long term, some of the NFV folks have been talking about that as well. Is like you can take OpenStack and say, hey, this is basically a special purpose hypervisor to go deploy this, this service chain out for an end customer.
Super cool.
Yeah.
Jeff, I've been hogging the mic. You got any questions?
Yeah, I mean, the only one I would want to hear from Mark is, what are you most excited about as far as networking goes, like in this next year? What do you see coming? What should we look out for?
The thing that excites me the most is you take a look at just kind of the rise of all the open source solutions that we're starting to see. You have a number of projects which are open source. Some of them are gaining momentum. Some of them are newer and bringing new ideas to the table. So those definitely excite me. Also taking a look at just some of the work that's been going on to kind of harden the solutions, like from the NFV folks, and trying to make the solution good for telcos. I mean, because when you want a dial tone all the time. But the nice thing is that while some people look at NFV if, hey, this is telco, it's actually beneficial for the entire ecosystem, because the problems they're addressing a lot of times are often just encountered in enterprise deployments too. It's just they have a different name or a different requirement. So that side, those things kind of really excite me, just looking at what people are doing, how they're hardening, how they're making it. Some of the open solutions are nice because you get a lot of just very diverse voices. But also at the same time, I think we're slowly starting to converge on, here's how we can make this problem simpler, how we can make it easier to operate. Because one of the things I always compared kind of Neutron in early days is like, it's the difference between like if you fly, you look in the cockpit of like say an older jet. I mean, there's switches everywhere. 747 used to take 3 people to fly it, and now you get on like a Dreamliner, it's like 2 guys, glass cockpit, computer interface, and it's like all that same complexity of the airplane is still there. It's actually even more complex, but the interface has changed so that it's very easy to operate. And so, that's kind of my hope. I'm hoping for the future is that we can further start refining that, and so that, in terms of networking and how it interacts with virtualization, is that we can take that interface and really simplify it so that it's all the power is still there, but day to day, it's very easy to understand.
Does that pose a threat to people who've been doing traditional networking for a long time? Like, what do these people do?
So the funny thing is, because that comes up too, and like, we'll go talk to people, and you get some traditional networking teams are very afraid of virtualized networking. They're like, I have to learn something new, and oh wait, this is going to put me out of a job. But what we've often found is it doesn't really threaten their careers. It actually kind of enhances it, because a lot of times what you find with networking is that some network engineers are doing very mundane, rote tasks over and over and over because of the complexity of the system, instead of actually tackling the problems that are, more enjoyable to tackle, exciting, kind of more fun. And so what we found is that, when you can kind of automate out the mundane things, it's like you're actually freeing up people to go do cooler things instead of chaining them down to doing. So I've never really looked at it as much of a threat, as much as more an opportunity to kind of unleash a couple. A lot of people just kind of been chained doing kind of boring work for several years.
Definitely an exciting time. Look, that's I think an opinion that is shared by most. I mean, people thought, oh no, we're automating sysadmins out of a job, but it seems like they just get to work on bigger, better things if they have the aptitude to learn, right? Speaking of learning, you are G on Twitter, GTWMM, correct?
Yes.
Where can people find out more about Astara and Akanda?
Akanda.io is our website, and the Astara project, we are in the OpenStack Big Tent. So, in the repos are OpenStack/Astara, and then the Astara has weekly IRC meetings. Right now, with the time change, they happen at 12 noon, 9 a.m. Pacific on Mondays. So
Super duper. Well, Jeff, any last questions? You want to do the honor of asking the last question, Jeff?
Yeah, sure, Mark. So we like to ask this of all of our guests. Who we didn't prep you for this, so I apologize. But who are two folks that you'd like to hear on OSPod here?
So it's interesting because I was looking about everybody y'all have already chatted with, and I mean seriously, y'all have taken about my top 20 choices already. I think one thing I think would be interesting is to go find a new person to our community. I think one of the challenges, now that OpenStack is 5.5 years old, is taking somebody who's really looking at it with fresh eyes, because I think it's an interesting conversation, as sometimes I think we forget what a new person thinks about our community and how we interact. So that would, so that's not a name per se, but that would be always, I think, an interesting conversation. Also, I think it would be fun to round up some of the original people, because one of the cool things in this, you kind of had this kind of tract of people talking in Vancouver who had been there since the early days, kind of looking back, and now at 5 years, it's kind of interesting to go back through and then say, okay, what did we think 5 years ago, and what's the reality now, and kind of talk about, is it good, is it bad, because even within, because the community has changed so rapidly, but yet, the tenets of the community have stayed the same. Ensuring openness, trying to work, maintaining the 4 opens has been really cool, but we've had a lot of rapid change at the same time. So I think kind of looking back and saying, what are the lessons learned? Also kind of going back through and saying, if I was pressed, I would never do this again, and kind of letting the air out of the room, because I think if you talk to people kind of privately, some people will tell you, I would never do this again, pressed. It's like, this is one of the, in terms of design or something like that, it's like, yeah, that was a totally bad idea, but, we're stuck with it. And I think some of the new people don't understand some of the architectural decisions, and, they look at it and they're like, well, why did that happen? It's like, well, here's the backstory, or here's kind of, more the unusual stories of OpenStack.
I like that. Well, we've been talking about for a while doing kind of a panel. I think that'd be a great one to do. Is kind of 5 years ago and today with some of those folks.
Let's talk to people that have gotten acquired.
Yeah.
I would love to see kind of how things have changed. Randy Bias, I think, is one of our first guests. Mm-hmm. It'd be great to talk to Randy, find out what he's up to. Well, Mark, you are a wealth of knowledge. I can't tell you how impressed I am in your ability to convey complicated information in a simple way, even for non-network experts like myself. So thank you so much for taking the time to talk to us today, and we look forward to seeing you in my hometown of Austin, Texas at the next summit. Jeff, who's up next on the show?
So next is Ian Rabinovich.
Oh, Elon.
Oh,
yes.
Elon, is that it?
Elon.
Oh, okay, here we go. Elon, sorry.
He was with Yala, and now he's doing something different. That's cool. And then who's after that?
William Mapp.
William Mapp. Awesome. So we are back. Thanks, everyone, for harassing us to get back on. We took a short hiatus because both Jeff and myself have been traveling a ton, but as always, if you have any ideas, suggestions, comments, questions, complaints about the show, tweet us. Find us on Twitter. We're happy to hear it. Thank you again, Mark. Everybody say bye.
Bye, everyone.